So the first example we're doing is involving what's called the Hamilton method. It's the largest remainder method. So we are going to probably use the graphing calculator may be best because of the ability to store decimals more manageable. So I'm going to try to model this using the graphing calculator. So the Hamilton method or the largest remainder method, it's actually the math is not as hard as it is. So what's interesting that the Hamilton method was actually named after Alexander Hamilton. He proposed this method back in 1792 when the United States was really young. And this is where we were trying to figure out how to assign seats to the House of Representatives. So note that there's 435 seats in the House of Representatives. And what would be interesting is how many seats does Kentucky have? So if you want to look that up and text me how many seats Kentucky has in the House of Representatives, uh, text that to me and I'll add 5 points on to your score. So, and that's based on today's data, 2026. So this apportionment, again, is based on census. So if you do some research, we do a census every 10 years. The last one was in 2020, and the 435 uh, seats were reapportioned. So if you compare the seats in 2010 to the seats in 2000. I don't know when the census in 2020, so it may not have actually happened until 2021 or 2022 when they finally compiled the data. But you may see a difference in how many House representatives um, each state has. And that also ties into the electoral college that we use in our voting system. So as we move through the um, Hamilton method. Again, feel free to pause this video if you want to read a few more things about Alexander Hamilton. Um, our method these days is a little bit different than what he proposed, but it's still called the Hamilton method. But here's the Hamilton method in its original form. So we have the total population is going to be divided by the number of seats. This is going to be what's called the standard divisor. In other words, this is going to be what this is going to represent is um, the people per one seat is what this is going to turn into. So this tells me how many people share as a state one seat of representation. So we'll ignore this for the time being. So once we find this standard divisor, whoops, let me pause for a second here, get some of this math off here. So once we get the standard divisor, what happens is we find each group's standard quota. So this begins to apportioning how many seats each state gets. So the quota is going to be the population of each group or each state, and you're going to divide that by that standard divisor, which is going to tell me how to share the seats among the states. And this number we usually leave as a decimal. So again, in apportionment, quota is the exact decimal number of seats each group should receive. So we're going to leave these as decimals, and that's where our calculator is going to come in. And what's going to happen then is again, the quota is going to be the fair sharing, but again, we can't share a decimal of a seat. So this is when we round down. We give each state or group the lower quota. So we take only the whole number part, ignoring the decimal. So there's no rounding here. We just ignore the decimal part, and we assign those seats first. And then in step 4, we determine how many seats are left over. There usually is. And these leftover seats, what we do is we distribute the remaining seats by the largest remainders. So based on the largest remainder, the highest remainder gets the first available seat, and we just keep working on from there. So in our problem, in our homework, whoops, went too far. So we have this question one. So in the 2010 census, like we're talking about, that's when we do a lot of this reassigning, reapportionments, if you will. The population of state A in thousands was 4,800. State B was 2,958. State C was 4,533. What we want to do is we want to apportion 18 representative seats to these three states. Assign the seats using the Hamilton apportion method. So we just talked about that. So one thing is in the Hamilton method is we needed to determine the total population. Now, one way of doing it is actually add the thousands into the problem. So this really is 4,800, and thousands means add three more zeros. So that really means 4,800,000. And what we want to do is add to state B. We got 2,958 but thousands. So I'm going to go ahead and put that as 2,958 with three zeros. So that means 2,958,000. And then I want to add to that state C, which would be 4,533 and a bunch of zeros, three zeros. So that really means their population was 4,533,000. So the total population at this point is this 12,291,000. So our total population is going to be this 12,291,000. And what we want to do is divide it by the number of seats, which is 18. And this generates our standard divisor. So if I divide that by 18, this gives us then, so 682,833.333. So again, we don't round this, we leave it as a decimal. Then that's going to be per seat, if you will, one seat. So we really just look at the top part here. The one's going to be understood. So that means that for every 682,833 people, if you will, they're going to represent one seat. So that means people are getting represented by a seat. So now what we do is we want to determine how many seats each state gets. So the population of each group, which we have here, this is the first one. So we have this 4,800,000. We're going to divide that by the standard divisor, which is going to be 682,833.333. So if we do that math, so I have this 4,800,000 and then three more zeros. If I divide that by, and I'm going to just go up here and copy this and paste it down. That's now going to give me this 7.02. So I'm going to here write it as just 7.0, but I do have the decimal there if I need it for anything. So that's going to be A. So B, we're going to have this 2,950,000, 958,000, and we're going to divide that by the standard divisor. So 282, 682,833.333. So again, I'm going to type in this 295, it's not a 5, 2,958, and then three zeros. So that's the population. Then I'm going to divide it by that standard divisor again. And that's going to give me 4.3. But again, I have the real decimal over there on my calculator. So that's state B, and then state C, we had this 4,533, 4,533. So 4,533,000. Again, if I want to divide that by that standard divisor, a lot of threes. So if I type that in as 4,533,000, there we go. Then that now turns into 4,533,000. If I divide that by our standard divisor, that gives me then this 6.6. So these are what we call our quotas. So each group's quota. Now, what I want to do is just take the whole number part, and that's going to be what we call the lower quota. So A has 7 seats, B has 4 seats, and C has 6 seats at this time. So we assign those seats first. So if we add that together, we pick up on that the total seats assigned at this time would be 17. So what we need to do is figure out how many seats are left over. So we had 18 to start with. If we subtract 17, that means there's one left. So who gets that one seat? So the remaining seat is based on the largest remainder. So if we look at the decimal part, the biggest decimal gets the first seat. So notice how we had 7.0, 4.3, 6.6. 6 is the biggest decimal, the first biggest decimal there we see between those three numbers. So that means state C actually gets the leftover seat since it had the biggest remainder. So state C now jumps up to 7. So now we have a 747. So state A would be 7, state B would be 4, and state C would also be 7. So that's how the Hamilton method works, is you kind of find out how many seats each state gets to start with, and then you start divvying out the leftover seats until they're gone. And that's based on looking at the decimals.